So for a very long time, geologists were actually kind of mystified by this very unusual feature in South Korea. A unique bowl-shaped landscape that's actually referred to as the Jokjung-Jokye Basin. And not so long ago, Tim from Geology Hub released this very interesting video on what's now known as the largest young impact crater in the last 50,000 years. Because this is now referred to as the Hapchon crater, as in the last 5 years or so, various research papers have officially confirmed that this is actually the result of an asteroid collision that most likely happened within the last 50,000 years and involved a very large bolide, 200 meters or 600 feet across. Moreover, this was one of the more powerful explosions in the last 50,000 years, resulting in an explosion approximately 1500 megatons in power, something like 30 times more powerful than the most powerful nuclear bomb ever detonated. And this was, of course, a somewhat shocking discovery because, first of all, this makes it the first ever official impact crater in South Korea, but second of all, this is way larger and way more powerful than any previous recent craters known to us. Especially the craters from the Holocene era, when humans were already around and most likely witnessed them. For example, in some of the previous videos we've discussed the discovery of the Jinlin crater in China, that despite being large and somewhat recent, is actually way smaller than the one in Korea. This was only discovered in 2025 and was possibly formed 12,000 years ago. But it's only 900 meters across and only 90 meters deep, which is only a little bit smaller than the famous Behringer crater, or the Meteor crater as it's sometimes known, that's approximately 1200 meters across and 170 meters deep, and is one of the most famous features in Arizona. This one formed approximately 50,000 years ago as well. But the Hapchon crater seems to be 7 kilometers across, 42,000 years old, and 200 meters deep, which means that the meteorite that produced this was much larger and resulted in a dramatically more powerful explosion. The explosion so powerful that it most likely wiped out any human settlement that was living on the Korean peninsula around this time. But that's something that was officially discovered back in 2020. Today though, we're actually going to be discussing something else that was very recently discovered, and that for biology and for studies of earth sciences is actually really mind-blowing. Because we now actually have very important clues for the potential origins of life that were just recovered from this site. And so, hello wonderful person, this is Anton. Let's discuss this recent study that as always you can find in the description, where researchers have just reported discovery of stromatolites. And here this is something we have to discuss in just a little bit more detail, because it potentially changes what we believe about the origins of life on planet Earth. But first, just a few more details about what we know about this crater and why it's potentially kind of important. And so first of all, I've never even heard of this place before until I read some of these studies. And that's because this is a very remote location, and today is basically used for rice fields. In other words, until 2020, nobody living here or working here had any idea they were doing so inside an impact crater. Intriguingly though, this area seems to produce some of the best rice in the region that's apparently known to be extremely delicious. And so if you've ever wanted to taste space rice, this is probably the place you would want to visit. But the thing is, even on Google Maps, it doesn't actually resemble any kind of a known crater. And so here geologists had to drill for over 140 meters into the ground, mostly because they wanted to find out why this was such a strange shape. And here they discovered the telltale signs of an asteroid impact. In this case, various shatter cones and various deformations with inclusions of quartz that's usually produced by high-energy meteor strikes. And so here, by using carbon dating, they determined that this was approximately 42,300 years ago, confirming that this was the most recent very powerful impact crater on the entire planet. But around the same time, a slightly different series of studies was actually exploring something in regards to impact craters that was basically hypothetical and was based on some of the indirect evidence. And here's actually one of the most recent studies on this hypothesis that essentially involves understanding the origins of life. Now today, based on a lot of different types of research, a lot of different biologists believe that life most likely started around the formations referred to as hydrothermal vents, essentially formations that we still have today that are normally found deep in the ocean. But intriguingly, some of the studies in the last few years started to find these formations, or actually signs of these formations existing in the past, in locations where we actually kind of also found very powerful impacts. In other words, scientists started to find so-called impact-generated hydrothermal systems. And so here, when a large meteor hits the planet, because it releases so much heat and creates so much melted rock, as these impacts eventually cool down and fill with a lot of water, they seem to create long-lasting hydrothermal systems, or kind of like these hot, mineral-rich lakes that we usually find near volcanic chains. And in theory, this can obviously drive complex biological chemistry, and once again in theory, can also maybe produce some kind of early life. And so hypothetically, these systems can provide a localized warm environment even on objects that are not Earth. So for example, an object that might have an ocean, such as Europa or Ganymede, may also suddenly have these systems following a powerful impact, at least in theory. And this means that even simple chemical compounds may be able to evolve into something more complex and even form biological substances in just a few thousands of years instead of millions of years. And so based on this somewhat recent study, researchers discovered certain evidence by analyzing 3 specific impact sites that seem to support this hypothesis. First of all, the most famous one, the Chicxulub crater in Mexico. 66 million years ago, this was of course the impact that killed most of the dinosaurs. Then we have the Houghton crater in the Arctic that formed 31 million years ago, and the Lunar Lake in India that very likely formed 570,000 years ago. And this one actually still has water inside even today. And in this case, all 3 seem to contain signs of ancient hydrothermal vents, suggesting that impacts, despite being destructive, potentially also give life a new chance. And that means that these impact-triggered vents might have been more common than volcanic deep-sea vents during the first billion years on the planet. Which of course implies that there is a much higher chance that life possibly started as a result of these very powerful impacts that then formed hydrothermal vents, as opposed to just forming naturally from some kind of a vent that existed deep in the ocean. Or at least that's the implication from some of these studies. But in this case, this particular study was still kind of hypothetical, with the evidence still being kind of circumstantial. But that's until now and this Korean discovery from 2026. Because the discovery from April of 2026 is truly mind-blowing. And that's because the crater in Korea was hiding stromatolites. Okay, so what exactly is this, in case this is the first time you're hearing about it? Well, one of the most famous stromatolites is something we've discussed recently, and is actually the one in the Shark Bay in Western Australia. And these are essentially layered rock formations created by tiny photosynthetic microorganisms, such as, for example, cyanobacteria. And here these microbes eventually produce very sticky compounds very similar to cement, that glue together various minerals, forming these rocks. And over thousands of years, they eventually build up these layers that then create these rocks. And so basically each of these is at least a few thousand years old. And normally these are very important and kind of famous because they also represent the oldest physical evidence of life on Earth, with some of these dating back 3.5 billion years ago. In other words, this is a telltale sign of early life developing and becoming more complex. And that's why it's a major breakthrough if this was also discovered in the middle of South Korea. And so here we have several individual samples representing stromatolites that seem to have formed following the impact. And this was found along what used to be a shoreline of a lake that filled this region. Or basically this basin used to be a lake with the water eventually draining. And so shortly after the impact, this lake produced a lot of these stromatolites. And this is actually the first time ever stromatolites have been found inside a confirmed impact crater, directly confirming this impact hypothesis involving hydrothermal vents and, of course, potential origin of life. And so this kind of tells us what happens following impacts and how they actually seem to reset a lot of conditions on the planet and even allow new life to form directly on the site. Which means that meteorites can definitely create their own hydrothermal systems in a lot of different locations where we don't even expect life to exist. And so based on the analysis of these samples, researchers have now confirmed that this whole system and this lake very likely contained hydrothermal vents for at least 27,000 years. Or basically, following the impact, both the lake and the vents remained inside for nearly 30,000 years, allowing these stromatolites to form over time, with the heat from this impact providing a very stable, warm environment that permitted these stromatolites to bloom and thrive inside. Once again, literally in the middle of South Korea. And so, assuming all of this is confirmed, this is a remarkable discovery. Because for decades, the leading hypothesis was that life began inside deep sea vents that we normally find along the volcanic ridges. But based on a lot of this evidence from 2026, we now have this new contender, the impact hypothesis. The idea that life potentially started following a lot of powerful impacts that then created conditions that were perfect for a lot of simple life. And there's a really important reason why the impact hypothesis now actually has a little bit more evidence than the previous deep sea vent hypothesis. First, we have something referred to as the water paradox. And that's because while life does need water, too much water is actually bad. Mostly because for a lot of these very delicate biological molecules, too much water means that they actually have trouble maintaining stability. And so they need to have just the right amount of water and just the right amount of salinity. Then there is the idea known as the wet-dry cycling. Impact craters on land basically create a kind of a wet-dry cycle, with a lot of these cycles between the wet and dry seasons helping concentrate chemicals and encourage molecules to then link together. And eventually these links might even start forming something complex like, for example, DNA. And so the formation of complex molecular chains could have been the result of these repetitive wet-dry cycles, which usually happen after these impacts. And then we have the idea of fresh water versus salt water. In this case, early deep-sea vents were very salty, which can actually be toxic to a lot of the early cell membranes. But a powerful impact crater in the middle of the continent can be filled with fresh water that provides a much friendlier environment for some of this first life. In other words, lakes like the one that was produced by this impact might create conditions that are just so much better for life to form and to then evolve. And on top of this, there's the concept known as the oxygen oasis. And specifically because we know that billions of years ago, something happened on the planet that transformed it entirely, enriching it with oxygen for reasons we still don't understand. As a matter of fact, we don't even know why the photosynthetic life evolved on the planet or how it was able to do so effectively. Because billions of years ago, conditions on Earth were just a little bit too toxic. And so life had to find some kind of a safe zone to evolve. And studies from the Hapchon crater suggest that the impact craters might have served as these oxygen oases because they would provide just the right conditions and just the right amount of heat and minerals to encourage oxygen-producing stromatolites to grow and for photosynthetic life to then evolve. And so 3 to 4 billion years ago, a lot of these impact craters might have served as these isolated oxygen-enriched areas, forcing life to evolve and adapt to this new gas. And because impacts were much common back in the days, quite a few of these places very likely formed in many different regions. As a matter of fact, each of them potentially possessed a slightly different network of these somewhat bizarre biological laboratories. But when it comes to this particular study, one of the most important discoveries was the chemical analysis in order to confirm that this was indeed connected to this asteroid impact. For example, here by using osmium isotopes, researchers found a very specific fingerprint inside these stromatolites. The ratio matched the material that we normally find in meteorites and not the local rocks on Earth. And so that means that space rock components were directly absorbed by stromatolites, forming these microbial mats. And here they also contain a rare earth element referred to as europium. In most rocks on the planet, europium is usually rare. But in high temperature hydrothermal fluids, it becomes more soluble. And in this case, these stromatolites seem to show a positive anomaly, implying that they definitely grew in hot, impact-heated water, and not just cold water that you'd expect from a typical lake. And so by itself, this is a pretty big discovery, because first of all, it completely changes how we see asteroid impacts, and so basically now instead of just seeing them as destructive events, like the event that wiped out dinosaurs, we can now definitively say that they also spark new life and provide all of the heat, chemicals, and stable environments needed for life to potentially begin somewhere else that's not even Earth. And more importantly, this now gives us a new map for where to possibly find signs of life on other planets. So for example, we can now start looking for various craters on Mars, or even objects like Europa and Enceladus, in order to see if we can find something somewhat similar in those locations as well. And specifically by finding signs of hydrothermal vents, we might finally find signs of ancient life outside of planet Earth. But that's of course something that we still cannot do yet, because we would probably have to go there first. And that's because a lot of these geological studies would actually require drilling into the planet and retrieving samples. But at least for now, this is still a pretty exciting discovery and will potentially rewrite some of the textbooks on the origins of life. Now, we obviously need to find more evidence from other regions first, but that might come with time. And so until future studies or until we discover something else, at least for now, that's all I wanted to mention. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the 1 4% t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.